Hi, this is Kavati Sridhar, Assistant Professor in EC Department. Today, I'm going to discuss folded dipole antenna. Folded dipole antenna is a structure formed by two parallel dipoles connected at the ends of the create a narrow loop. That means two ends, two conductors are connected, joined to form folded dipole antenna. This is conductor 1, conductor 2. Its impedance is typically around 300 ohms, which is 4 times the impedance of standard half-wave dipole. Its bandwidth offers a wider bandwidth compared to standard dipoles, making it ideal for the FM and TV application. These high bandwidth or high impedance is used in the FM and TV applications, especially in the Yagyu antenna. We will use common uses. Often use the driven element in the Yagyu. In the Yagyu, we are using as a driving element antenna to provide the better match for the transmission lines. So by this folded dipole antenna, we are using this folded dipole antenna is using in the Yagyu antenna by transmission lines and to giving the better radiation to the all parasitic elements. Yes, this is structure. Here we are giving the feeding point so that current will flow like this. Two conductors are giving one power supply so that this current I will be distributed like I by 2. That means current in the same phase in the two conductors. When the current is given, this conductor will start the generating the radiation. That means it is having the self impedance, that is Z11, and here self impedance this one Z22. When current is flows like this, it is starting the generating the radiation. So this radiation will affects on the second conductors, and this second conductor radiation effects on the other conductor. So first when current flows in this, here we are having the self impedance, that is Z11. In this one, second one, self impedance is Z22. Due to the this one, it will affects on the other. That means due to the induced EMF, we are getting the other radiation, that is impedance, that is Z21. Due to this one, second one, here it is Z12. That means this conductor is having self impedance Z11 plus the effect of the second conductors due to the induced EMF into this second conductors. Again, it start the radiation. That effect is called as the mutual impedance by the other conductor, that is Z12. And here also Z22 is a self impedance for the second conductor, and Z21 is a mutual impedance for the second. Totally how much? Z11, Z12 plus Z22 plus Z21. Due to the less distance between these two dipoles, the impedance almost all same, that is Z11 equal to Z12 equal to Z22 equal to Z21. That means 4 into Z11, that is 2 square Z11. That means 2 is the two dipoles. The folded dipole is combination of two dipoles. If it is tripole, that means for suppose we are using the another conductor, that means tripole, that means 3 square here. When we will use the three conductors, we will get the 3 square. Here we are using the two dipoles, we are getting the 2 square. That means 4 into Z11, 4 into Z11, 4 into 72 ohms, 2 square into 72 ohms. That means by using two conductors, we are getting the square times, that means 2 square, that is 4 times we are getting the more. That means high gain we are getting. A folded dipole antenna is modified from the half-wave dipole antenna in which two parallel conductors are connected at both ends, forming a closed loop. The feed point is usually applied at the center of one conductor. It is widely used as a driven element in Yagud. Already we are discussed in the Yagud antenna. Here, this part is driven element, which is having the power supply. That means it is conductor. All these are the parasitic elements. By having high gain of this dipole antenna, the all parasitic elements will get effects and it will start the radiation. That's why we are using in the Yagud antenna. Working principle. When RF signal is applied, as we just now we discussed, current flows through the both conductors. The currents in the two wires in same phase. Because the conductors are connected at the ends, the antenna behaves like looped half-wave dipole. The radiation pattern is similar to half-wave dipole but higher impedance. The radiation pattern means what are the radiation? Suppose this is the axis of folded dipole antenna. The radiation will be like this, perpendicular to the radiation and a minimum to this axis. Next, advantages: higher input impedance, that is 300 ohms, better bandwidth than simple dipole, good impedance matching, less sensitive to nearby objects, commonly used in the antenna arrays. Applications: this high impedance dipole antenna used in the TV receiving antennas, FM broadcast antennas, Yagud antenna, driven element, VHF communication systems, and radio receivers.